Okay, so I think it's time and maybe we can start. The session is being recorded, so.
Okay. Good morning. Good morning, all of you. And then it's pretty nice to see familiar faces as well as faces that are curious to know things, right? I think it's a wonderful time to be in. Okay. So I'm not going to take too much time. I think I leave the time and discussion to the experts out here. I'm mostly a bystander, right? So I'll tell you what is this all about and how you can make use of it and in both sides of the game. Right. And the very purpose of Industry Connect, as we actually constrained that to be, is kind of bridge between industry and academia. So the industry actually goes in its own pace, and we all actually recognize that almost every second being in the industry. Academia per se has a lag. So lag of 10 years, 20 years, I think now it is about 4 years of lag. So whatever you study, I think it's going to be at least 4 years in time lag compared to what has been actually used otherwise. But with the advent of technology, that gap can be bridged. But when you bridge the gap, I think there is a possibility of really missing out on a few things which are fundamental. So I think the gap should exist, but gap should exist in the foundation because foundation is not going to change. So foundation is going to remain the same, be it physics or as we call STEM, science, technology, engineering, maths. They're not going to change. They're all going to be there, and they're going to be there for a longer period of time. And one interesting thing that we notice is most of the time, application is actually what is changing. So how we are going to use the STEM part of it in whatever we do, either building tools, building technology, building platforms, building products. I think that's where the whole thing is changing. And why are they built? And the built for their applications also. I think that is where the whole change is happening. So our logic of this Industry Connect is to really provide that kind of a platform where you can test your foundation as well as its application as it happens. So that way you actually get to know two things, right? One, okay, whatever I am learning as a student or as a faculty I'm teaching to my students, how relevant is this going to be for the industry when they actually pass out? So gone are those days when actually companies used to come, then maybe in the second year, third year, they make an offer, right? And they also engage with you guys for about a couple of years more before you join them, as well as a couple of years later you join them in terms of on-job training, certifications, etc., to really prepare you for the job. That time is gone. So now I think it's ready. If you're ready, you get a job. Otherwise, I think the jobs are actually not there for people who are thinking that I can get some time while in on job to learn and then be useful. I think those times have gone. So it's important for both faculty and students to know what is industry is expecting and how do we really equip ourselves every day so that it actually becomes seamless thing to really transition out and get that going. As I said, that's for two reasons. One, application is changing fast. Then the bridge between or the gap between the what you study versus what is required is also actually merging closer to zero. But in that process, don't leave the foundation away. Be very strong in your foundation, but at the same time, find out how is the application going through and how can I really equip myself to be there. That is the primary purpose. So there are multiple ways of doing it. One, you have a lot of online courses that you can take, right? And those online courses are also made by people who either practice or preach. So you actually get a lot of content. And there is also a lot of tool sets available today to really tell you about summary of a technology, summary of a problem that you can solve, etc. They all can actually give you pointers. But the powerful learning happens through peers. People who are already done what you actually are doing now, at the same time, people who are practicing the industry, when they come out to you, really tell about okay what they're working on, how they're working on, how they see the whole thing is changing, and if you are a student or a faculty, how can you really make that leap happen between what you're studying today to what you're helping students and move to a level where they can actually seamlessly work with what industry expects. So this is a peer learning, peer discussion kind of a platform where experts in the industry, as we have today, Mahesh, Sachin, and Kiran, they'll actually walk you through both technology piece of it. What are they working on? What does the technology say? Which gives you a flavor of the application. And then also come back to you and then tell, okay, how can you prepare yourself to be really ready for the industry the way they're expecting? Maybe you take 2 years to come, or next year you're coming, or you're already sitting through campus. But I think this will actually help you literally knowing from people who practice. as to what's going on and what you should be knowing better. Okay, that is the kind of a platform we thought we'll create so that it becomes useful for people like students and faculty to really benefit. And also for the industry guys, I think we also benefit. But the questions you ask, we get to know, okay, beyond the standard questions of what should I do to get into your company? Is there a portal where I can apply for internship? Okay, these are all standard questions. Okay, so standard questions are okay. They are required as well because that's what bothers the students and the faculty. But the questions you ask on, okay, what should I be doing? What should I be teaching? How should I be really looking at what is in front of us? If there is a threat, how do we really look at that? And is there a way you can actually come back to us and help us with something which is meaningful for us to practice for every other student? Questions like that, and deeper questions like, okay, what is this AI all about? What is this technology all about? What is this domain of automotive all about? Is it going to change? If so, how is it changing? If it is merging with another other industry, how is it literally happening? I think if you ask such questions as well, even industry folks actually get to know, okay, what's in your mind and how can we really help you to bridge the gap and also become useful to you. Okay, I think that way it is a mutually beneficial kind of a platform. So my request to experts is, yeah, be an expert, walk the people through whatever is happening, and also help them understand both the challenges as well as the opportunities that exist for them. And also, maybe a kind of a roadmap one can follow if they're in the path of really becoming people part of the industry. What should I be doing today to tomorrow? Also, for faculty, okay, if they're teaching, training, what they can really go and teach and how they can really collaborate with the rest of the guys to make sure that it is very useful. I think that is very valuable input that you give it to them. Students and faculty, again, the same story. Please be open, ask questions. Maybe chat window is there, put questions or send out emails, not necessarily in this call itself, later as well. Okay, reach out to really figure out exactly what answers you require. Then that I think we are there to really help you out and be happy to do that. Okay, so that's what I thought I'll just tell you about in terms of what is this Industry Connect and how you can make use of it. Is that fine?
Sure.
Thank you. Go ahead.
Okay. So thank you, Hebar. So just for everybody's information, Mr. Hebar is the founder and CEO of Industry Connect and Buoyancy. And no, I am Chinmay. I work with Hebar, and we take up a lot of initiatives of this kind under Buoyancy. I also have my colleague Shachi, who's also a team member of Buoyancy. And we'll be continuing this session. So this is the first session, and we are planning this as a monthly session where we look at different industries, different technologies, and try to bridge this gap. So continue to follow us. So okay, coming back to our sessions and experts, we have 3 experts lined up today who will be sharing their perspectives. I think let me quickly share a quick intro slide here. So we have first speaker is Mahesh Kumar Mehta. Welcome Mahesh, and thank you for being here today. So he's a digital transformation leader from Bosch Global Software Technologies, and he has a lot of experience with IoT, MES, and Industry 4.0. And Bosch being a automotive major, he'll definitely have a good insight to share on automotive. So welcome Mahesh. Over to you.
Okay. Thank you, Chinmay. Thank you, Abba. Thanks for this opportunity. I'm quite happy to connect on this Industry Connect, in fact. The reason for the happiness is being I'm connected to young minds. So it means I'm feeling young as well. So I'm going back to my college days. It really reminds me of the days when I was also at this stage and I was also looking ahead, like, what could be the next scenario? What could be my next thing? I think this is a very good connect where you have an opportunity to connect with the experts out here and then figure out what could be the next move of yours. So with that, I think my introduction is already given by Chinmay. Thank you, Chinmay. So today I picked up one topic, so wherein I would like to sow a seed of entrepreneurial spirit in all of you. Inside Bosch, we also have something called as startup events. So we pick up one idea, a problem statement, and then we run it. And then there is a separate funding done to it, and there is a separate guided. A mentorship is also being provided. As part of that, we are building one of the products, which I'm going to brief you. So that is catering to mobility sector. So where we have innovated one of that audio-based technology, and then we are providing the safety in the corporate mobility. So with that, maybe let me get started with the presentation. Yes, so the innovation. So what the innovation? I was talking about the innovation. So it's like guided process, right? Where process where businesses run through and then develop products. Okay, so what exactly innovation should talk about, and how do we cater to any of the innovation, right? It should be desirable, feasible, and then viable as well. So any innovation that falls in these parameters, I think we can go ahead. And also we at Bosch, we look at also like, customer segment. Is it available? Is it not available? Is it viable to do it? So all of this. So if you see, Bosch Innovation Framework talks about catering to the ambidextrous organizational requirements as well. So, when we know about this innovation, so innovation is not just about new and noble ideas, right? That the idea is there and then that's done with it. So it's all about having to know a field where I should be innovating, right? Identifying a noble problem or a real teething problem where it needs a fix, identifying it, and then validating a hypothesis, and then building scaling up model, and then launching a product. Right? This is how the innovation happens. It is a journey. It is not just an idea that it ends when you have a new idea and then it doesn't end there. But it takes a lot of effort. In fact, if you ask me, the typical life cycle of any idea from scratch, from the ideation till launch, it would take around 2 to 3 years. So that's the power of innovation, or that the timeline that you'll be looking at it, right? Okay, so when we talk about this innovation now, what is the problem statement that we picked up at Bosch, right? So since we are working at mobility, corporate mobility and mobility solutions, so we thought let's look at the problem that is really bothering existing corporate sector. So one of the teething problem that we identify is corporate mobility, where employees are transported from home to office, right? So this is a journey. Like morning you pick up a cab and then you reach office, and then evening same back to home. The typical problem that we see here is rude behavior of a driver. How do you fix it? What is the evidence that you did that, right? And then how do you handle it? Another one could be like unexpected incidents while you're traveling. How do you address that? You need somebody to be with you, right? And then other could be like, there could be unmet expectations. Even the passenger may ask to drop you somewhere else, whereas the dropping point is something different. So these are the teething problems, and this would definitely add to your productivity, your satisfaction, and the smooth journey to your office and back home. Okay, so when we know about this problem, so we picked at this problem, and then I will also talk about who all are involved in it, and then we'll let you know about the solution that we already figured out. The key players, it's more or like your Ola and Uber as well, team. If you say like, in the Ola Uber also we face that the driver could be rude, right? And then there could be unmet expectations as well. Like instead of dropping somewhere, he could be dropping somewhere else, and the route that is taken could be different. So that's the problem. And then who all are involved in it? The end users. End users is us as employees, right? And then when it comes to the other parties, corporate, who are helping you take your commute from home to office and office to home. Another one is the one who is coming and bridging this gap between organization and employees, the mobility service providers, right? They come in. So the challenge and the demand, the challenge needs an integrated solution where we can bridge all these gaps. Okay. And then if you see, like, recent survey states that the corporate mobility is broken, it's time to fix it. Why? What is the problem? Because most of the employees feel that, commute plays a vital role in their job satisfaction, because that is where they start and with that is what they end, right? There are compliance related issues, rude behavior, and then people also taking for granted the corporate commute as well. So these are the problems that are already there in the existing scenario. What are the key challenges at each sector, like in each of the key players in the corporate mobility? If you take up the end users, they could be like non-functional emergency systems. So though there is a system which is mandated by government to have the SOS call in every taxi services, but does it work? Do not know. So that's where one of the challenges that end users face it, like unauthorized route deviations, right? All of a sudden, the driver would take a different route. They do not know what is the reason why it is taken up, right? Then wrong driver has been assigned to a particular vehicle. We used to have it when we started with Ola and Uber. The driver assigned was different, and the one who take you on the ride is different. So all of this, if you take the corporate driving, because Many companies do transport their employees during the night hours, right? So during that time, they would be working in the day as well as night, and definitely during the night travel, they would fall drowsy. Then how do you make sure that your drive is safe during the night hours as well, right? Wrong pickup and wrong drop out points, and the lack of evidence. If something is going wrong within your journey to office and to home, where is the evidence that you can raise a complaint so that next time it is not repeated? And mobility service provider also, for them also, it's a challenge, right? They do not know whether the panic buttons that are there in the taxi working or not working. Unreliable GPS tracking, so delayed incident reporting, right? So once you're done with that incident, after your travel you report it, then by the resolution it comes, I don't know what would happen. So these are the key challenges in each of the sectors. So potential cost of inaction is huge. Okay, it adds to your absenteeism, your productivity, and then many of the people feel if the transportation to their office or back home is not that great, then their job satisfaction will also be affecting. So these are the potential cost of it, right? So unlike earlier days, the transportation is not only limiting to basic point-to-point transportation. Now it has evolved. Now it has become real-time safety monitoring has become prime importance. Flexible scheduling is also of paramount importance. Premium vehicle standards are needed. Means your cabin vehicle condition should be clean and neat. Advanced safety protocols are needed. So these are the need of the hours. And why it matters? Because business continuity is dependent on them. Employee experience is definitely one of the prime importance, and then corporate responsibility, that employee safety during transit is also a key factor for any of the organizations. So these are the teething problems in the mobility sector. Okay, so with this, if you understood, so what is that from door to desk, right? Seamless journeys and delighted employees. How are you making sure that it is taken care? So before I run through other slides, I would like to play a short video, so which will talk about Right Buddy solution to all these problems that I talked about just now. I hope my desktop is visible now.
Yes, sir.
The
Yeah,
video?
it is.
Is my video visible, team? Chinmay?
Yeah, yeah.
Okay, sure. So I'll play this video, which is a solution to the problem that I talked about. Yeah.
You can check the sound. I don't know if the sound is there. We are not getting any sound from the video. There is no sound. Maybe you can brief what is being shown.
Mahesh, can you hear us?
Sorry.
Okay, the audio was not available at all. So you can just brief what was the video about. Yeah.
Okay, sure. I included the sound as well. Okay, fine.
You can just brief
Yeah,
about
yes.
what it was about.
Yeah, sure, I will do that. So even after I included the sound as well. So we have built a product by name Righty to address the challenges that I spoke about in the corporate mobility. So this device is called as Righty, okay, which is replacing your existing dome light in your vehicle. So what are the functions of the device are? So we come up with the innovative idea of having a audio, right? Because we also want something not to be recorded inside the cabin other than the driver. So we have two devices that are installed in the vehicle. So one is the dome light, which is the right buddy, replacing the dome light, which acts as your light as well as your buddy during your ride. Another one is the dash camera, so which will capture only the driver eyelid movements so that we get to know whether he is drowsy or not drowsy during his drive, right? So that is one function. So where we first primer function that most of the industries or most of the organizations facing are driver being drowsy when he's driving during the night hours. So we detect that and then we nudge him via this device. So this device is audio enabled. As soon as we detect that a driver is drowsy, we nudge it like, driver, you're drowsy, and then maybe stop aside and then start your journey again. So that's one thing. So which is taken care. Like no one has to tell him like he's drowsy, not drowsy. Even if he's distracted, also it will let him know like you are distracted. Do not be distracted. So just a 2 seconds of window is what he has to blink his eyes. If it is beyond that, we detect it and then we let nudge him via device. So that is the device that is already there in the vehicle. And after that, what happens? Here, if you see, a driver has to talk about, or maybe he has to say a few words, like, there are two methods of authentication of a right driver. So one is via mobile OTP, the way we do it in the current taxi segment. Similarly here as well, and also voice authentication. So we know that the right driver is on the cab. Okay. So that is another feature that we make sure. And whenever there is a deviation in the route, right? So your home to office, there is a fixed route. If a driver is taking a different route, then we nudge him, like, he has to say why that route is being taken, right? There could be many reasons. There could be a road work going on. So he has to take a deviation. There is too much of traffic. He has to take a deviation. So all these things had to be noted down. Then only the route is allowed. Then we know that any distraction or any anomaly that are happening within the cab are are taken care and are noted down. So we do have evidence of every anomaly that is happening within the cab. Another one, say for example, you meet with an accident or you meet with unplanned incidents, right? So that time, whom you contact with. So there is an emergency button that is available on this Righty device. When you press it, then it will directly go to emergency center, and then your incidents or your grievances will be addressed then and there itself. This device is two-way communication. Even the passengers inside the vehicle also can talk to it, and then even the emergency center can also talk to the passengers that are there in the vehicle, so that there's a two-way communication and you feel that your emergency is being addressed. That is one of the features. So these are the basic features that are built within this device, so which makes sure that employees are feeling safe when they are commuting from office to home and home to office. So you have a buddy within your drive, and then that definitely give you a peace of mind when you're commuting from your office and your home. And apart from that, if you see, we do have real-time monitoring, like wherever you are, the way we capture in our taxis, Uber and Ola. So you will have the real-time monitoring as well here. Right? Even if the driver is looking at the mobile phone, we make sure that we nudge him that he is distracted. That also will be nudged via our device. See, he is feeling drowsy, so we'll also nudge him. So this is the camera that is being, installed on the dashboard. So where it captures the drowsiness of the driver. And then we have the dashboard as well at the command center where they look at like in emergency incidences, SOS call alert, so that someone will be there at the emergency center and they look at what is the situation, and then immediately they will be taking an action to address that emergency as well. So real-time dashboard is also available, right? And then if employee is feeling uncomfortable, they can press the SOS button like we discussed. So this is how the dashboard looks like, right? Complete data is available. Your route distraction, your anomaly detection like emergency reporting, and then your cabin conditions, all these things are monitored via this one. So this is a video. I think since audio is not available, so I had to talk about it. So I'll quickly run through the other details as well. So this is how exactly a day in a corporate commute happens, right? So you start and then you pick up from your home, you pick up the cab from your home, and then you have the route that is defined, and then you reach office, right? And then same happens when you come back. So this is how the day in a corporate commute will be, happening in a day to day. So like I spoke about the capabilities of this innovative product that we have built is accurate reporting, and then driver vehicle assessment, automated incident response, right? Boarding and alighting confirmation. So what exactly each of the players, like we talked about three key players, right? So one is end users, corporate, and then service providers. What do they get out of this device? So one is the real-time monitoring via Dash. No, alert system is already available. Status dashboards, what's happening with each vehicle. Each vehicle is mapped to a driver. If you see, when we play the video as well. So when we talk about evidences, right, you need the video as well. So we capture that 30 seconds of video when he is falling asleep. So that also evidence will be available so that we can nudge them or take necessary actions to correct that, right? So and then if you see the, how do we create value for each of the sectors? So for the corporates, it's a lower legal risk because we have the incidents and the evidences for those things. And then better fleet control as well, because you know what's happening during the commute. And then happier employees because they feel like, they are taken care. How about the service providers? They have the win more contracts. If they have these devices, then organizations will also feel, yes, in this services, my employees are safe. And then reduced costs, right? When it reduced cost, manual work is reduced out there, prevent problems. And then what is for end users? Peace of mind, and then comfortable rides. And for all the other, for transport teams also, it's a real-time visibility, incident management, fleet optimization, enhancement. So this is how we are creating value across the complete corporate mobility sector. Okay, so this is all about Righty that we built as an innovative product, and this product is being funded by at central level, and then we, unlike any other organization, we are not having any separate department or anything. We are just a garage where we come together. So the product is having hardware, software, firmware, cloud systems. Even we use a lot of AI ML engines as well here. So the complete system is available with this product. Yeah. So that's about Righty. So now I am open for any questions and clarifications.
So Mahesh, is this product commercialized already?
Yes, now it's still in the testing phase. So we are already, testing it with one of our customers, and then by this year end, we'll be going live as well. So it's already ready. It's just that now we tested as well. Test data is available, and it will be going live by this year end.
Okay.
Yeah.
So I guess, anyways, I think there are no questions right now. I think we'll move ahead.
Yeah, sure.
Chinmay, if I may.
Yep.
I think a couple of things, Mahesh. One is, I think,
Yeah.
given that the audience is going to be students and faculty, I think a couple of things I would like to paraphrase what you just said and also leave it on the table. Okay, one is, see, the kind of work companies do is an interesting question people actually have in their mind when they're in the college. Okay, and also when it comes to innovation, they will really look at things that are bigger than life. Okay, but I think there are two things that we need to take away from what you just showed. One, innovation can be simple, meaningful application of what is required in day-to-day life. That also
Yes.
is a kind of botheration for a corporate like yours, wherein you invest time, energy, money to really get that done as well.
Yeah.
So the day-to-day problems students face or faculty face or anybody around their families face can also be turned into a problem worth solving. So if you have a problem worth solving, I think in the current generation of industry, where maybe there is a feeling of jobs being dried out and campus interviews not happening and all of that, entrepreneurship is one way people have to really explore very well beyond what they used to do before. Because being on your own, being innovative, being setting your own laboratory, really garage, work with guys to really make sure that you solve a problem, also showcase a solution, which used to be the case with projects and internships and everything else. Now more and more it is really required as a skill. Wherein, okay, you identify a problem, yeah, make it worth solving. Solve it in a way that you can showcase, demonstrate it, and scale it. And that itself adds a lot of value to the CV. Okay, in colleges, you actually have laboratories, you have faculty, you have time, you have projects. If you can really pick and choose problems worth solving and then convert them to solutions, make sure that students do the projects that way and then enhance their CV, their opportunity to really get to corporates is going to be much higher. One. Second, if that turns out to be a good one, you can actually go and then build your own venture and then move on with life as well. So instead of being just an employee, you can actually act as an employer as you go further as well. So the abundance of access to resources and technology and pieces, everything that is required, and with an eye for a detail of a problem worth solving and solving it, I think will be very powerful. And thanks, Mahesh, for showcasing solution as simple as this, which is meaningful for you as well to everybody else, and how even within corporate you guys can be entrepreneurs to really build a solution which is required for the company than just saying, okay, this is the job that you need to do. So I think that spirit, I guess, is required both in students and the community that actually supports them as well. I think the students can take that aspect. Okay, explore problems that are worth solving, build them. You have resources, and if you actually need guidance and tech support or whatnot, reach out. So there are people available to really guide you to get there. Maybe you create the next magic that we are all looking forward to, right? Which may actually land you in a very good job, or you can actually start your own company. Both are practically possible. And thanks, Mahesh, for this.
Thank you, sir. Thanks a lot. Yeah, we like you said, we work like a startup here, and we are not that much bounded by Bosch process and systems. We create and we curate our processes and then run like a startup. In fact, it's a company that we're running in, and then all of us are like named like in a company organization itself. Like we have a CEO, we have a COO, so we have a CTO. So all of these like designations are there, and we work like one company within the Bosch itself. This is one of a kind product that is being developed within the Bosch. Yeah. Thank you.
Wonderful, Mahesh. Thank you so much. Over to you, Chinmay. Chinmay, you have to unmute.
Oh, I'm so sorry. Okay, thank you, Mahesh, for this valuable insight. Our second presenter is Mr. Sachin Patidar. He is a VP and Head Vehicle Engineering at Daimler Truck Innovation Center, India. And he is going to have a very interesting insight on innovation. And just to let you know, he has already authored a book on innovation. So maybe he'll also talk about it. Over to you, Sachin.
Thank you. Thank you very much. Yes, innovation is the key here. But today I will talk about what exactly going on in automotive industry. What are the skill sets required? What's trends, right? Technology, and what's going on inside, right? How
Yeah.
do we ready for that? And I'm going to share my slide. Let me know if it is visible.
Yeah, just one request. Do not share the entire desktop. Just share your window.
Yeah. Am I audible?
Yeah.
Yes, I'm sharing only window, and I think it's working. Looks like, yeah.
Yeah.
Can you see the complete slides, right?
We can see. Yes.
Just a minute. I have to make this now. Okay, right? Let's start.
Yeah.
Good morning, everyone. And as Chinmay told, let's talk about something which is more useful to create innovation, right? Today, my topic is about automotive engineer. It's about you, it's about us, and how automotive engineer influencing the future of mobility with skill, technology, and trends. Or maybe we can say will influence, right? They're influencing when they're doing an in-house project, as Hebbar told, and they will influence when they join us. Let's look into what I'm having. So my outline is I'm going to quickly focus on trends, technology, and skills required to build technology to cope up with the trends, right? Or build new trends. Trends. This is we divide these trends, and I learn a lot of from Hebas, from a mega trend to the micro or mini trends, right? The mega trends, what we see around, we know there are social transformation happening, the rise of the new cities. We know now small towns are becoming cities. The techs are getting infused into the village, like in previous this innovation. We have seen that this gadget can go in any car, right? Not only from the corporate transportation, but there could be many use cases. Localization of the global views. Now the global views are actually uh, coming into the local areas. People are able to use whatever they have. Whatever earlier cities have, now villages also have. And the other important thing is aging. Every year, around 200 million people are celebrating their 60th birthday. The world is aging in general, right? This change, this trend in social call for a different level of innovation in mobility or in anyone else. Along with the social change, what we are experiencing, the emotional transformation is also happening. Gen Z, as we know, and you are many of them thinking very different from what we used to think or our earlier people used to think, right? Virtual and real, the boundaries are going away between virtual and going, right? The new minimas are getting formed. What we need minimum is that's it. Earlier, if you have some car, it's like that's it. I made my life. Now, car is new minimum. Or somebody said, I don't need car. I just need a device to transport from A to B. And we are also with AI going to territory of the unknown emotions. We don't know what the new combination of the emotion might come up, and our products, our innovation should able to meet that. The third is economical. We have seen that our purchasing power, people are now able to, almost every third Indian is able to have a mobile, right? Our access to the global products is easy. We are redefining our luxury, right? Definition of luxury was earlier, if I have a home, it's luxury. If I have any basic stuff like basic car, it's luxury, but we are defining. And again, the next level is economical because of this global disruption, unknown. We don't know. It's a real need or it's like just a hype. The fourth trend, and all of you know, and I start with unknown. What we know is what we know, that AI is coming, the quantum physics is coming. But when the AI and quantum physics and the huge compute power come together, we don't know right now that what kind of technology will come up, what kind of new situation scenario will come up. We are just imagining. These are the five changes, our trends. And when we look these changes and trends, they really influence each industry. And automotive is one of the biggest because we move the people, right? We move the people from A to B, whether you call road transportation, air transportation, water transportations. We are the skeleton of the world, and we are getting impacted huge. Now let's look into the trend in a graphical way in for automotive, right? Very specifically, we are shifting toward hybrid technology. We told that we'll build electric vehicle, 100% electrification will happen. No, it's not happening. We have seen that, and you at last I'll show how many companies died in this quest. the shift is toward hybrid, which means that you should know electrical, you should know mechanical, and the next is software. Software-defined vehicle are going to be future. We call it iPhone on the wheel is the future. Electrification and adoption, yes, the rate it's going on. The problem is that how we are going to make our vehicle more autonomous. Okay, we can solve the problem, but the major problem is also how we are going to live when autonomous vehicle, semi-autonomous vehicle, and the old vehicle coexisting in a road where some vehicle are very sensors, other vehicles have no sensors, right? How they are going to talk to each other, or how the whole infrastructure look like. Other trend in our industry is sustainability. Sustainability is a town of the talk. In automotive industry, we go for all scopes, 1, 2, 3 for the sustainability. In manufacturing, we would like to come up with new ideas, new innovation, when our solutions are sustainable, where we can recycle our complete vehicle. Connected cars, we don't want now mobile to get connected. The car should be able to talk to each other. Car should be able to talk to our home also. The AI is getting infused. BMW, Mercedes, our companies using all possible ways to integrate our AI into automation into the vehicle. Our dashboard will be driven by AI. And at the last, what exactly is stopping us or pushing us are the policies. And current situation is very tough. Geopolitical impact on EV market are huge. We stopped our electric vehicles in US. We stopped building right now electric trucks. We have trucks sitting in our campus ready to sell. Not many buyers. We have technology now, but it's very expensive and it's not supported from the government. And they are not encouraging right now or pushing or giving subsidies. And therefore, we have to really go from pure EV to hybrid or maybe refine our engines again. So the trends nowadays, as a sum we can say, are very short-term trends. Of course, long-term trends could be EV, but if all vehicles become electric vehicle, from where will generate this much of electricity? Ask this question to yourself. It is impossible to have all electric vehicles practically. We call them that in future we will use the energy mix. There will be electric vehicle, there will be hybrid vehicle, there will be gas vehicle, different fuels. All energy mix will survive. All technology mix will be there. Everything will be mixed, so there is no single trend. Okay. Now, what technology? Technology is we just split into the four again. We call it a zero emission. All of you know, most of you might think it's going to be future, but it's not only the battery, as I told. It's a battery, fuel cell, hydrogen, hybrid, or any non-fossil fuel will also come up together. And that's what I mean when I said energy mix. The next one is in technology is connectivity. In vehicle connectivity, almost we are there. Vehicle to vehicle connectivity, it's happening. Vehicle to house, vehicle to everything. So the paradigm of connectivity going to increase day by day, and this technology is going to stay irrespective of whether you have battery vehicle, you have fuel cell vehicle, or any kind of the propulsion system you have. Connectivity is going to have. Now let's look into autonomous. There is a huge buzz around autonomous vehicles. It has two meanings. One is for the trucks, one is for the cars. For the cars, many companies are there, including Mercedes-Benz, where we have developed a technology, we are piloting. If we also look into the trucking industry, can we have autonomous trucks? And one of our key project, ATG we call it, autonomous vehicle. We bought a company in the US, TAR. Along with that, we are building our autonomous truck. But the use case is very simple, highway use case, hub to hub use case, not for the city drive. For city drive, it could be small cars, or maybe the taxi, which is already in California and some states, Google, Tesla and Google is already trying to implement that autonomous. But when we talk about India, it's a long way to go. Here, we should learn about ADAS, Advanced Driving Assistance System, like, and Bosch has expertise on those stuff, and the Conti. For us, it's very important that we reduce our dependency on drivers because distraction is increasing day by day. And in my last slide, I will show the impact of that distraction, like road accidents. Autonomous is one of the way. Right now, if you look at this story, I always say we used to have, and I learned from my seniors this story that we built vehicle because the horses was creating a lot of problems. So we replaced horses in 1886 with the engines. Now, 100 years, we realize that engines were wrong choice because it's creating a lot of emissions. So we are replacing engines with the battery technologies. Maybe it's right or wrong, I don't know right now. But we are again seeing that we are getting nuisance from the drivers. So we are removing driver from the ecosystem itself. And that's how it will go. We don't know what next will do. But what we know right now is that autonomous is one of the need of the hour. The fourth technology, and it's not a technology, and that is my personal view. It's a confluence of the technology, expectations, regulations, cities, all will come together and create a big nexus of confusion, relationship, opportunities. Now, whatever way you want to look this, but the confluence of technology is going to drive the world at the next level. And this is how, from industry, we see this whole technology spectrum. Let's look into the skills. What do we need? So I divided the skills into two skill sets, right? For us to become a good engineer, to become a good professional, we need to have combination of these two skills. And I'm big fan of the soft skills because, and Bosch guys know that we work with German colleagues, we work with global colleagues. We hire an engineer here in India and we hire an engineer in US or Germany. The way they come up with their presentation skills, the negotiation skills, the kind of the depth, we miss that completely here in India. We hire people and we train them to talk in English. Come on. We train them to talk or present things. Therefore, I would say the first skill set, which all of you and all of us should emphasize, call as a foundational skill, basics, the core of the basics of engineering. We are missing our guys joining company and doesn't know what's thermodynamics law, right? What are thermodynamics law? The thermal guy is working and doesn't know three laws of thermodynamics. This is happening. They don't know what is stress and curve, or they don't know the basic coding or basic stuff, Python, cool. Basics anybody can tell, but when you come to the industry, you need to be depth, and that 4 years of engineering should teach you. And they try to teach you, but are we learning? That's the question. And the people will succeed who knows the foundation and fundamental, because the application side will change. It will be battery, electric, hydrogen combustion, everything, but the core equations will be the same till the Newtonian physics are there. If the quantum physics will come, things might change again. Then that also we need to learn. Second is soft skill. How do we communicate what we know? How we interact with each other? How we interact with the global colleagues? How do we interact with the people who doesn't know technology? People who are really developing technology, and people, if we are using technology, if there's no communication, then we miss something. The third pillar, like I told in technology confluence, here again, the cross-functional. People who are doing mechanical engineering, if they only learn mechanical, people who are working on automotive, only work on automotive, electrical, only electrical, electronics, software, AI, they cannot do anything then in future. Because at application side, this all knowledge comes together. Collaboration between the discipline is must. If you are a mechanical engineer, if you have a friend, try to make it in electronics, AI, and have kind of a discussion that how can we come together to create magic, right? Magic happens when we combine this. People come to us with the core knowledge, when very high level knowledge of mechanical, no use. They should know how motor works. Motor has electrical, mechanical, and electronics, and they should know how we use now AI on this motor to make it more skilled, more refined, right? This is about the function. The fourth skill is again connecting the dots between, and this I learned from Habar, connecting the dots between the different industries, right? The agriculture industry, construction industry, transportation industry, healthcare, fabrication. How do you move technology from A to B, B to C, and learn and use various use cases? This is my take on the skills, and I say data analysis, system engineering, problem solving skills are the foundation skill as on today. Everyone should have it, irrespective of your domain discipline. I put those in the second context as a core technical skill. Now you are talking about the automotive engine. What we should have? We should know about the battery technology, power electronics, electrical maintenance, and autonomous sensor fusion, lidar, radar, cameras, AI, machine learning algorithms. The depth has to be there. If you want to go focus in the high-tech software-defined features, automotive software development, V2 as communication protocols, 5Gs, edge computing. You see, automotive engineering is not anymore automotive engineering. It's wholesome engineering. And this applies not only to automotive industry, any industry this applies, right? Software defined vehicles, as we spoke, all over the air, real time operating system, as we discussed earlier in the innovation from Bosch. Cyber security, nowadays it's common everywhere, and for us even more important, because if you are driving a car and somebody hacked your car, you are gone. Sustainability, come on, this if you really want to have longevity in our world, we should have sustainability, and we should go and understand what is life cycle, what is the life cycle of a product from cradle to grave, or can we recycle completely and never go to the grave, right? And in-depth understanding of data and digital transformation will really help, that if you can create a digital twin. And if you believe me or not, many companies have implemented digital twin and they are getting benefited out of that, right? We need to learn, how can I create a digital twin of any components? It could be a machine, it could be a factory, it could be a car. How can we create at the end a digital twin so that we can play around and all that? If you want to go and marketing and sales, yes, there are also digital sales, marketing skills. Without marketing and sales, like we spoke, your innovation is just invention, right? Innovation is something has to be sold to the mass to generate the profit. So these are the in-depth technical skills required if you really want to survive in this cutthroat, high-tech market. Well, what's more here? Very simple slide. We talk about startups, and I would like to now give you double click what's happening in our automotive industry. I just asked ChatGPT, give me the top successful automotive initiatives and top fail, and you see the equation is more or less equal. It's very easy to say, okay, let's start the startup for automotive, but to create execution around that vision, to build a vehicle, to sell vehicle, to maintain the complete life cycle of vehicle is very difficult. We all know Tesla, we all know BYD, we all know Tata Motors, Ather Energy, Ola, Neo, Lucid Motors, Rivian. We all know that ChargePoints has successfully implemented, but we don't know how many failed behind that, and there are reasons. The reasons, and if you look into all these reasons, funding, of course, funding is a reason. The other reason is the technical ability. You can say that I can make a autonomous vehicle which will use in airports or the ports, but how do you build that? And the companies like Faraday, Dyson EVs, these are the global companies, right? In Indian companies are not written here. Many, and you see the log 9 in last 3 years. I was tracking that company, amazing company for advanced electric batteries, material, and we try to connect, discuss, and right now it's in deep trouble. I would not say it's failed 100%, but in deep trouble. And that's because we think only at the component level or we think at the technology level. Log9 was able to build a small battery. And we went to Log9 and asked, guys, can you give us a battery? We can try in our trucks, or maybe we can change our liquid battery with your solid battery. They are not able to scale up. They find challenges, maybe. Maybe they have a solution now, but right now they are going through a tough time. And that's the difference. In academia, I was in IIT, Delhi, Bombay, IC, Bangalore, everyone. They have a lot of innovation, a lot of killing ideas, a lot of proof of concepts. But we miss how to scale it, how to make at a production level, how to sell it, how to commercialize it. So any idea is only idea or invention or hobby until we are able to really make it commercial and make it happen. Right. It also happened with the car renting services, lithium, and various reasons companies struggle and fail. I'm not the expert on this, but just I'm trying to say that one of the reason is technical capabilities, and this is your moment and time that you can really fix this. Well, the last slide from my side. This is small my initiatives, and I spoke about the nuisance created by drivers. Of course, an accident happened because of the vehicle, because of the infrastructure, and because of driver. Every day, every day, about 470 people die because of the road accidents in India. It's day or data. Sorry for the spelling mistake. But point I'm trying to say that by the time we'll conclude this session, 100 or 50 people might have already died because of the accidents. We need to build a culture. We need to build vehicle. We need to build transportation. But many things are not in our hand. The one thing which is in our hand is to have right awareness. And Safe Mile project is my personal initiative. Let's see how it goes. Follow me in this Insta just to create an awareness to reduce accidents. And in future, let's see how we contribute towards drivers' well-being and overall safety. And this is a collective responsibility of everyone's, from students to industry, from home to offices. It's our collective responsibility to make every mile into a safe smile. With that, thank you very much for this time. Looking forward for a question if you have anyone or anything. Thank you. I'll stop sharing.
Okay.
Sir, I have a question.
Yes, Raj.
Well, sir, I'm Raj Chaudhary from Priyadarshini College of Engineering, Nagpur. And I myself consider as a very fortunate that I have got this opportunity. And I would like to grateful to Mr. Chinmay Kale, sir, for sharing this opportunity to our college professors. And from them, I got this opportunity. So thank you so much, sir.
Sure. Thanks. Yeah.
And
Ask your
well,
question.
yes, sir. I have so many questions, but I'm not sure about it. My juniors once asked me this question कि भैया हम लोग अभी ये चीज़ sir, will it be okay if I will talk in Hindi?
Sure. Go ahead.
Okay, thank you, sir. माई जूनियर्स आस्क मी कि भैया अभी हम लोग ये चीज़ सीख रहे हैं, फॉर एग्जांपल हम लोग ऑटो कैड सीख रहे हैं, हम लोग कभी L&T के जो कॉलेज का MOU साइन हुआ है तो उन्होंने जो कोर्सेज करने का गया मैन्युफैक्चरिंग से रिलेटेड हम वो कर रहे हैं, जहाँ पे भी जो अपॉर्चुनिटीज़ मिल रही है इंटर्नशिप के रिगार्डिंग या जिस भी रिगार्डिंग हम वो कर रहे हैं. बट स्पेशली देर आर 3 डोमेन्स आई विच आई हैव हर्ड की एक डिज़ाइनिंग, सेकेंड मैन्युफैक्चरिंग प्रोडक्शन एंड थर्ड वन इज़ थर्मल. सो फिर हमने किस फील्ड में जाना बेटर होगा. दे आस्क मी सर दिस क्वेश्चन. तो ये क्वेश्चन मेरे माइंड में सेम है एंड सेम मेरा भी क्वेश्चन ये है कि हमने क्या करना चाहिए सर इन तीनों में से.
So Raj, आप पढ़ क्या रहे हो? What is your branch? Are you a mechanical student?
यस सर, आई एम मैकेनिकल इंजीनियरिंग स्टूडेंट, सेकेंड ईयर मैकेनिकल इंजीनियरिंग स्टूडेंट.
Okay. Sachin, you want to answer? You want me to answer?
I mean, Hebar, please, you can.
Okay. See, Raj, I think there are a couple of things out here. Okay. One is
Okay, sir.
while you're in second year of engineering, don't look at specialization too deeply. Okay. So
Okay,
whether
sir.
you look at thermal, whether you look at manufacturing, operations, don't worry too much about that. Okay. So primarily, you have to look at all of them to really know the subject. So what does
Okay.
it really take to be a manufacturing? What does it involve, right? What does it involve in operations and operations related work that need to be done? Thermal, yeah. What exactly is thermal? What is thermal engineering all about? And what is thermodynamics? And as Sachin was saying, know the fundamentals very, very well. Okay,
Okay,
that's
sir.
one way of really looking at it. That's one. Second, see, one of the charts that Sachin showed was very interesting. Right. I don't know if you can really bring that back, Sachin. I think that will be useful. The technical skills slide, I think last but to second or third.
I have also taken a photo of it, sir.
Okay. So I'll use it and answer your question as well as I think summarize this. The reason is, see, this is the one. So if you really look at it in the industry, right? Industry is actually classifying it like this: electrification and battery
Okay,
innovation.
sir.
It requires manufacturing, okay? It requires operations. It also requires thermal engineering very nicely. Okay, you got a
Yes, sir.
cybersecurity and connectivity. Again, how exactly cybersecurity plays its role in manufacturing, very critical to note. And also when the car goes on the street and the issues that you face with cyber crimes and everything else becomes important as well. So ops and manufacturing go together even in this case. Look at any of them: sustainability, autonomous vehicles. So we call software defined vehicles. So software-defined vehicles cannot actually run on their own. Okay, there is a electromechanical part that is essential for that to really work with. So all these things, right, really require all the three domains you talked about. So industry looks at these things as a way forward to really put their money in. And for engineers like you in the second year, in the third year, if you really get your fundamentals right, and also look at what does it really mean by meaning an autonomous vehicle, what does it mean? In that, what is mechanical role? What is electrical role? What is electronics role? What is software role? How much of each of these things you need to know? If you learn that, then it becomes easier for you to really move further and also build your career. Okay. So you know these things. Okay. This is the skill set that's required. But each one of them is not just that. Okay. The skill required there is underneath this. And that's what you study. And while you study, appraise yourself with what do these things mean and how do they relate to in whichever line that you would like to go after. So keep an open mind, but look at the trend and at the same time make yourself useful in the domain that you have selected. That is very critical.
Okay, sir.
Thank you, Sachin.
Thank you so much, sir.
Oh, that is a very useful slide. I think another thing, Sachin. I think the question I had for you, if there was no question here, was this. See, I keep telling if I wear an investor hat, all investors actually want is their money to be protected forever.
Yeah,
Okay, so we
exactly.
would rather invest in things that do not die.
Yeah,
We don't want to invest in things that actually fly off and then not land.
yeah,
Right? So that is where you see investors back out of business or back up on invest. So if you really look at automotive sector, that is not going to die
yeah,
because human beings need to move from one place to the other, cheaper, faster, better is
yeah,
always there, and it's going to really continue further and further up, right? So when you actually look at that way, automotive sector is a green sector. It's always remains green. It'll have its challenges in terms of the dream they have for selling more cars versus what they're able to sell. But automotive sector per se will not go because
no,
the joke is this, right? If I don't sell a new car, I definitely my aftermarket business that year will be actually doing really well because the cars on the street should be maintained as well. So the aftermarket actually picks up. And, new car sale, you get a point, maybe 2-4% profit. Aftermarket, you actually go after 80% profit. So, the whole story of automotive is actually, yeah, new or old, but there is always an innovation practically possible. And at the same time, the industry is not going to die. So that is purely based on mechanical, manufacturing, industrial skills, Raj. Okay. So automotive is not going to go anywhere. Manufacturing is not going to go anywhere. right? And anything that you build as capability, it actually helps you really succeed yourself in the whole thing. You may actually find it difficult in the beginning to get a good job, okay? But be patient. Learn and take a job that comes in your way. But the career can be for about 40 years or so, okay? You can't decide everything today. It's second year of engineering, 40 years you're not what you're going to do, but be strong and pick up this. This industry is not going to go anywhere. Okay, don't have to worry.
But I second that. And this industry, because if they believe during COVID, if there's no trucks, when we are in trucking company, right? And our purpose is for all those who move the world.
Yeah.
Our purpose is for all those who move the world. We move the world actually. Our drivers move the world. If there's no movement of the truck, you will not get milk, groceries. The world will stand still. Industry is going to be here forever. The the shape and form of the industry will change. That is a transformation, the digital transformation. And my take to all mechanical engineering engineer guys is that don't think mechanical is a mechanical. We have to add intelligence on the product. So this is era of the intelligence product, right? So we have to think, but intelligence cannot work only with the dumb product. Correct. The product also should have ability to adopt that intelligence. The friction between component, if it is there, then your AI algorithm to have a smooth operation will not work. You need to generate a low friction surfaces so that your thermal energy is low and you can get more output of that. AI will enable to get more output. The more output, the function should also be ready, right? So the fundamental innovation happening at the Bosch on the injection system, the engines, batteries also on technology, implementation happening at our end. We are also developing things, and the software-driven vehicle is on top of that. Vehicle need mechanism to get actuated, right? Without actuator, what software will do? So that's what Habbar is also saying. But when we design actuator, we should develop that skill set, that how it will get better and better and add intelligence, right? Okay, great.
Very good.
Thank you.
Very good, wonderful. And also, don't forget the last slide, what Sachin said. Okay, safe mobility
Yes,
story,
sir.
right? You guys can create wonders. I've actually seen one of the examples of the solution, Sachin, okay, in Nepal a couple of years back when I was there. So there was actually, I saw a few set of guys walking in. I think they were half blind. They were not fully blind. They were half
Uh,
blind. They could see, but hazes of it, they can't see, right?
mhm,
One of the guy in the front was actually wearing a kind of a bell on his neck.
mhm,
It looked like a bell, but I was wondering as to what is this bell about. But you know what they've done is, if there is a vehicle coming in front of you, you don't know that the vehicle is coming to you, but the vehicle guy should know. The driver should know that there is a person coming in there, and he or she cannot actually move easily because of their disability, right?
mhm,
What these guys have done is, this is a small vibration sensor that rings a bell and lights
mhm,
up a small LED. So if
mhm.
there is a vehicle approaching, based on that vibration, this actually both creates a bell as well as blinks a
Well,
light on top of their dollar, kind of a pendant that the guy is wearing.
mm,
So the driver will know, okay, no, there is somebody
mm.
walking in, works in daytime, works in nighttime. That's such a beautiful innovation,
Yeah,
just to really help both the person as well as the driver, because most of the time accident don't happen just by one person. Right? It also
yes,
happens because of both guys involved. I panic and the driver is panicking, both create a problem. So these are
yeah,
simple solutions to create safe mobility where you were, because you need to be protected. At the same
yeah.
time, you should allow that other guy to really help you out. They just created simple vibration sensors lighting up an LED and making a sound. So amazing. I was so happy.
Uh,
Sat through asked them, okay, where did you get this? Who did this, right? And they actually
mm,
said, no, there is one school out here, and the school kids actually designed it for us.
wow.
Right. So it's not a big guy sitting in an AC cabin in the fifth floor of the building, right? It is always like people who are there in the road. They know the issue and they know the problem, and you can always spot a problem worth solving. And get that instinct that, okay, I can solve. Because by being an engineer, your primary thing is to solve a problem worth solving. Okay. First, identify the problem, just solve the problem. Okay. You will actually do your career really well. So that's how the career gets shaped. Okay. Thanks, Sachin.
My purpose, yeah,
Good, good.
just I close. My purpose is always refine engineering and engineer. That's our purpose.
Absolutely,
Yeah,
absolutely, absolutely.
great.
All
Thank
the
you.
best. Thank you so much. Thank you. Thanks for Raj. Thanks, Raj, for questions also. Okay, Chinmay, over to you.
Yes, thank you, Sachin. I think excellent insight on the skills and trends on automotive, and I think this discussion will definitely be of a lot of value. I think we have in line a third presenter, Mr. Kiran. Let me share his quick intro. Able to see? Yeah. Welcome, Kiran. I think Kiran is also from Bosch Global Software Solutions, and he's an expert in industrial automation. He's a senior solution architect, having 20 plus years of experience. And I think we are happy. I think Kiran has already done a couple of beautiful webinars with us before on IoT, on control systems and all. So welcome, Kiran. Over to you. Oh, Kiran dropped off, is it? One second. Let me check.
Check with him. I think, Raj, any other guys, any other questions if you may have, you can ask me. Kiran is back.
Oh, okay. Yes.
Hello, sorry.
Yeah, you
My
got dropped off, I think.
yeah. Network issue.
No, no worries, no worries. So
Yeah.
just welcome and over to you.
Yeah, thank you. Let me know if there is some disconnection in the network. Huh?
No, right now it's good.
Fine then, yeah, thanks. I'm sharing my desktop. Is my screen visible?
Not yet.
Screen is visible now. Oh,
Yeah.
oh no, it's
One minute,
on
yeah.
again.
Kiran seems to have some network issue.
Kiran, you want me to share? You can send the doc to me.
Yeah.
Kiran, if you want, you can switch off your video. That will save some bandwidth for you.
Correct, yeah.
Oh, I got it now.
Yeah, it's coming up.
Okay.
But if you want, you can switch off your video.
Yeah.
Yeah, done. How about now?
Yeah.
Working
looks
fine.
good.
Go ahead, please.
Yeah, fine then. Somewhere my Bosch internet is getting into trouble. Anyhow, I hope it's with this one. Okay, thank you. So I hope the introduction has been done. Sorry for that network issue. So this topic, what I'll be focusing will be on this convergence in the landscape of industrial automation. So thanks first of all for this session, Siva sir, and then Chinmay and all the team. And of course for Sachin to talk about the safety aspects, and then the Mahesh was talking about the safety aspect, and Sachin focusing on the software defined vehicle and hybridization perspective and a lot of interconnection. Basically this is where we would be heading towards, whether it is because of whatever reasons driven through technologies. we are trying to see from the angle of business first and technology next. That aspect is supposed to be there in everything. So with that, of course, now to give a brief overview, just to kind of relate to a question what Raj just mentioned, like Heba sir tried to say that, okay, need to focus on the core and also have some patience. So kind of some uh, pointers from my own journey, wherein which I started my career as a maintenance engineer, wherein which I started to focus more on the electromechanical and software maintenance. Then I moved on to become a software developer, wherein which I'll be focusing more on the assembly and test bench for manufacturing, programming in those areas. And then went on to move on designing some softwares for entire automated test equipment and control software. But at that time, if professors, you could have were aware that in 2009 and 2010 we had this kind of a big recession period, and that I took a decision to kind of move on to other technologies where I'll be more focusing on operation technology. I was thinking that this thought process would not be fitting anymore. I want to grow even in from the IT space also, or at least the OT IT bridging kind of. That is how I started to work on even Industry 4.0 and the IoT applications using the edge device and mobile devices and all. So if you can see that way, from what we traditionally think in one perspective of industrial automation, there is a widespread of possibilities which will be available. Hopefully, I got opportunities in these areas in Bosch. I could able to the kind of get into those kind of projects. In that way, further moving forward, where I was more focusing on the individual software architecture, I kind of thought, why not become a solution architect? That's how the solution architect interest grew in me, wherein which I was trying to provide Industry 4.0, IoT, and digital twin solutions. And I also completed my TOGAF and Open Groups Level 1 architect. So with this way, my journey of solution architect went on, and now I'm also focusing on some leadership topics in competency, innovation, and mentoring. So kind of to put in this context, there is a lot of opportunities available in let's say software industry and other parts of industry. I'll also touch upon how come other parts of industries would be also relevant, specifically from a multi-domain or interdisciplinary aspect. So in that sense, my agenda would be more on the from an industrial automation perspective, what is that convergence we are trying to see? Sachin mentioned about hybridization perspective in only vehicles. Imagine the same concept in the entire industrial perspective, whether you are trying to apply industrial automation for an automotive industry or other healthcare or any other industries. The perspective of so-called convergence, the mix and match is what is happening. But at the same time, while we are focusing on the mix and match, some kind of standardization, architectural changes or shift we are also trying to see. That's how. What would be the current state? What is the change drivers which is trying to kind of break these kind of barriers? And also what is already the future which is already unleashed? Some of them are kind of visible in hand, some of them are yet to be explored, but already it has been unleashed. And what do we get out of this from the opportunities and challenges within the industry and academic bridge perspective? We'll also focus on that, and finally, some valuable conclusion. So with this agenda, what we will be focusing is, why are we first of all trying to have this kind of convergence? And that how we will address this part, whether through technology, enablement, or any other things. And what is that we are trying to see? So this is the answers we would be focusing on. To start with some perspective, you would have already known this so-called industrial revolution. We started with mechanization. Then we thought that, okay, only mechanization would not help. We'll focus on electrification, because at that time, late 18th centuries, we had this electrification in availability, and because of that one, the electromechanical or electromechanization of the systems happened, wherein which assembly lines were trying to produce mass products. And then we thought, okay, why only electromechanical? When computers are available in late 90s, why can't we add automation to it, whether in the control level or in the personal PC level, so that it would be more efficient? That's where the automation came into picture. When automation came into picture, then we started thinking that, okay, automation is excellent, going good, but something can be still optimized. That is how digitalization came into picture. So, where you could see that IoT, analytics, and even cloud for that matter. And now with this next phase, what again we are trying to see is whether we will call it as redefining luxury or any possibility that we can explore further. The new trend of Industry 5.0, what we are trying to say here is the customization or personalization, where every product would be more personalized, and there would be definitely human-machine collaboration. It is one aspect of it. We can try to say that, okay, it is more machine-based, but definitely there will be a human-machine collaboration also. We'll dwell upon these topics. So why all it started is where we say from an industrial automation, we have the so-called automation pyramid. It had been since long, somewhere around 1990s to even recently, it is still prevalent. But when we look at this structure, wherein which this pyramid tries to say, at the low level, we talk about every sensors, actuators, and devices. That's a field level. And then these sensors, actuators are connected to the control level, which are whether PLCs, discrete control systems, or the PID controller, something like this. And these once controlled should have to be monitored and controlled from a manufacturing process context. That is where the supervisory level would come into picture, wherein which you can explore the SCADA and HMI level. Then comes, for certain things to be controlled, somebody have to give some sequence or command or some kind of workflow instruction, what to be done now, what to be done next. That is where the planning level would come into picture. There, that manufacturing execution system or so-called MES came in here. And then how do we try to do the right from the requirements to the logistics aspect, the entire management planning. So the entire enterprise resource planning also was put in. This automation pyramid was also kind of called as ISA 95, was trying to address the operation technology, which was more focused on field level controller and supervisor level, and also information technology. Now, our scope would be more focusing on the convergence from an operation technology. Yes, it is applicable for even information technology, but predominantly it will be more impacting the operation technology here. So for the engineers and the students out here, when we look from an industrial automation, there is everything available for you almost for all the fields. Be it mechatronics, whether it is you're a mechanical engineer or an electrical engineer or electronics engineer, there is always some mechatronic systems in the production line or a manufacturing line. Those things would have still to be connected to this electrical system. And then finally comes the software to deal with this, whatever industry 3.0, 4.0, and future 5.0. It can be having the same HMI, SCADA, PLC, and even others, let's say, software elements to it. Finally, what we do finally, we will have some kind of factory ecosystem like this to do some kind of product. And obviously that would be through some kind of a production line or machineries. This is how an entire factory automation looks like, wherein which, of course, it might be possible that even other branches of engineering would be also relevant over here from a process engineering aspect. Beyond the mechatronics part of it, even the process engineering is also relevant. From this aspect, we'll think what would be the current state. Till now, we told about automation pyramid, how did it work, and then what are all the elements in factories now. The current state, on a high level, we are trying to say that this landscape is more fragmented and limited. What does it mean here is the first and the foremost is the vendor lock-in. What do we mean by this is, imagine this, we are trying to develop a software, control software, whether it is in a PLC or a PC or anything, which may try to have some kind of applications like pick and place, robot picking and placing something, or even trying to assemble a product or testing a product. All these software are right now developed on a particular specific hardware. That is where the platform dependency is being created. We will be having multiple vendors trying to develop the software on a platform A, which cannot be running on the platform B. This is the biggest disadvantage. And it has been estimated that by McKinsey in 2019 itself, 90% of this industrial IoT or Internet of Things platform has this issue of trying to make any change. Why? Basically, the software logic is very kind of targeted towards a specific hardware. It is very tightly coupled. That is what we are trying to say. And what does this add upon for the business here? It is estimated somewhere around 20 to 30 percentage of this total cost to ownership would be increased on the business when we try to use this proprietary system. Of course, there are other elements to adding up to it, but this is how this would be impacting the business from having locking to a particular vendor from an hardware point of view. The next challenge would be the integration. Because we had this multiple vendors, one also example of integration complexity is because we had this multiple vendors, we used to connect with a lot of other proprietary, let us say there is a standard communication protocols and then some custom middleware and all. What it is adding up again? Basically, again, we are finding it too many things in one connectivity or one, let's say, purpose, fitting the purpose. Every time when we try to add something, it will add to some kind of failures. And now we need to identify where is that failure. That is where now you can see that a lot of production lines have the so-called machine downtime, which is impacting their profit also. Again, now when we try to add something, there would be again latencies. And then when we try to keep these multiple things, there is definitely a possibility of this cybersecurity and other, let us say, even for that matter, safety related issues. Somewhere we are trying to see that there will be a technical depth when you have these issues. Too many things are to be done for a simple change. That is a huge technical depth. This is the problem of this integrating all these legacy systems or the other, let us say, multiple vendor system for giving some outcome. Even in the current, let us say, a few 5 or 4 to 5 years before, this was a huge challenge. The trend is changing, of course. We'll see what is that. But from a integration complexity, this is what it is. And at the same time, think about traditionally what do we do in this industrial automation is from an operation technology point of view, we bring in this so-called the PLC programming in a traditional IEC 61131 standard, what we call it as ladder logic or ST program or whatever other related technologies related to IEC 61131. Generally, these are specialized skill, which means not everybody would be trained on these things. The other way put, me being an electronics and communication engineer, I haven't heard about a PLC program. Only after coming to Bosch or some kind of maintenance activity, I used to get knowledge on this PLC program. And again, it is a very specialized skill. You can do a simple program to a high performance, safety critical PLC program also. Similarly, when you think in that sense, when it is specialized skill, it is still not possible to integrate with other complex algorithms or APIs or DevOps integration. This is where we try to tend the modern way of IT environment. This limitation is still existing. And of course, we do not have other programming languages support beyond this ST or ladder logics or basically the IEC 611. Typically, if you see most of the industrial automation from an OT, that is the operation technology point of view, this is the challenge. And then, of course, even Sachin touched upon this one, the aging. One could be the aging aspect of the skill gap. That is, the experienced automation engineers have been working with a lot of legacy system. But the new software developers who are more comfortable with these modern languages, whether it is Python or Go or even for that matter Angular and all, would find it very difficult to adapt it. That is what it tried to say, that 75% of the industry find the challenge in getting the right skill for the digitalization. At the same time, we find the generational gap. This is again a big problem, wherein which we focus from a Gen Z point of view, the modern IT system. But from an experienced person, it would be more legacy system. This gap is always existing. And because of this, there is always a slow adaptation, which means to say, when some new generation software developers would try to come into this industry, the adaptation is very challenging. Why? First of all, this is deep for them to understand. The second is it might be even from the unappealing sense, because that is how the mindset is triggered, that I would want to be working on certain, let us say, AI system or some other modern languages and all. But that unappealingness is also still there. So these are the main, let's say, current state of the industrial automation, which is forcing something called convergence. And specifically, if you see from the current state, what is that change drivers we are focusing now? Basically, we are trying to see a shift in architecture. Of course, I'm trying to only notify certain architectures, but there might be even other, let's say, standard ones. But at least for me, where we have started with this so-called ISA 95 as a pyramidal architecture, is we now shifting to a more network architecture. This is where, whether you imagine it as a connected vehicles, imagine now it is interconnected machines in the shop floor or the manufacturing setup. This is how it goes. And what does this ISA 95 extended version tries to suggest is, it talks about a lot of activities to be done, but it doesn't talk about what system would we be implementing, which one, which hardware or let's say a control system would try to implement. It only talks about what to do. So then it will try to decouple these things. That is how we will be having something like process control, manufacturing operation management, or sometimes we call it as MOM. And again, the business planning and logistic activities, very well defined. But it doesn't talk about the systems that would be more implementing these things. Similarly, the other architectural shift is what we call it as open process automation standard. This is from Open Group, and recently, when I say recently, since some 2 to 3 years or even 4 years, we are trying to see what would be the impact or the benefit of adapting to this standard. This is basically what this Open Group tries to claim or try to portray is a standard of standards. What they try to say is, this is more a process control architecture, which is not at all dependent on any proprietary system. And if you see in that sense, if you see this way, it is very, very highly loosely coupled. It's not tightly coupled to any particular, let's say, systems. It does provide some integration in existing ISA 95 also, which means to say, if you could have seen the pyramidal architecture, some of the platforms only supports level 4 functions of ISA 95. Some of them supports the level 2, 3 and all. So in that way, all are these things have been integrated through something called Open Process Automation Standard Connectivity Framework, or OCF in short. That's how these so-called distributed control nodes, what all these are distributed control nodes, are being interconnected, and it has its own way of activities in individual function levels. This architectural shift is kind of bringing some clarity that what would be the control system doing will be independent from what system it is working, which means to say it more focuses on the so-called software or process angle of it, and then where it is being finally implemented, whether it is from the supplier 1 or supplier 2, doesn't matter. That is how this integration would be very smooth and seamless. These are some of the typical, let's say, architectural shift we are trying to see. With this, what is the benefit? What we are trying to get is something like this. First of all, it has been seen with these, and new technologies has been kind of introduced, and then somewhere it has been also multiple technologies are being kind of getting into convergence. Practically, whatever we think as of now, whether we try to say from the hybrid perspective, interconnection perspective, or even in the manufacturing, we talked about even sustainability. All these things, if you want to bring in from your, whether you are a mechanical engineer or an electrical or a software engineer, how can you try to contribute? Of course, it has its own opportunities and challenges. At least what it can be benefiting to the business and as well as the academic point of view is something like this. First of all, from a business angle, if you see, one which is more focused on, we talked about software defined vehicle. The similar aspect is in the industry or manufacturing, what we call it as software defined factory itself, or sometimes call it as software defined manufacturing. The root of this one is hardware independent platforms. Till now, we saw the vendor lock-in systems wherein which we have this control software very tightly coupled to the hardware. This hardware agnostic platform is trying to have apps 1, 2, 3, 4 virtualized and isolated with the hardware. Imagine as if it is again the same analogy of mobile on, may not be the wheels, but at least mobile phone for manufacturing. The same aspect is being also introduced. That is the start point of this hardware independent platform. So here we try to isolate all these apps with the hardware through some kind of virtualization or containerization platforms, and including the real-time scheduling is also possible. And of course, if you see in this aspect, there is a seamless integration with modern IT systems. These systems does support new programming languages, and also there is something called IEC 61499. Traditionally, we saw about the PLC programming with IEC 61131, but it is quite possible that the 61499 would be the front runner. Why? Because the same control application, what was done, it is still will be a function block, but this function block would be decoupled from the hardware artifacts. So that is where the hardware abstraction is happening. And already there are some systems in market, something like Codices and Bosch own Control X automation, ignition, and U controls. These are providing systems which you as a process engineer or a software engineer can program using Codices or Control X automation in a particular, let's say, platform, and then try to implement or deploy it in any hardware. That is how it will be the future. What would be the advantage of this? Of course, when you try to see when we had this vendor lock and other things, and again system integration problems, we did had this lot of downtimes in the machine. What it is estimated is almost 30 to 50% of machine downtime would be reduced with this kind of hardware independent platform. And again, 60% effort to design and test and commissioning is also reduced. Now, if you see from this angle, we are trying to say there is a lot of opportunities for the software developers to use the modern IT system to work on the control system aspect. And what is to do with the hardware developers then, when we try to say from an embedded point of view, or let's say even from other, let's say real-time application point of view. Definitely you will start thinking about certain hardware which is very, very flexible, which can run multiple softwares. That is the That is the path at which we are trying to go. And again, McKinsey is trying to suggest that specifically in the age of AI, there will be definitely multiple softwares running on some flexible hardware. Instead of you seeing in the shop floors one PLC connected to one machine, it could be quite possible that certain advanced kind of system, whether it is advanced PLC or other advanced controllers, flexible controllers, one controller itself can connect to multiple machines. This is how it would be focusing. Why? Because we'll be even trying to focus from apps point of view, that is a software defined factory perspective. This hardware independent platform would enable that. Other advantage, specifically the no code or low code development. This is where uh, answering Raj's question, this low code, no code will technically democratize your automation things, which the other way to say, it will empower you. You are a mechanical engineer or a chemical engineer or an electrical engineer who are very specialized in your own respective domains. You can now use this so-called no-code, low-code development platform. You as a domain expert or a process engineer or a maintenance engineer can simply change the workflows of a manufacturing process just by drag and drop or some user in something like intuitive UI. That is how it tries to say out here. You can try to think what should be changed. You don't need to be a programmer. Of course, yes, some low code platforms are also available wherein which for a particular maintenance engineer who could be much familiar with the programming skills can leverage this one to change certain things more scriptable in nature. But otherwise, it will be more in this ease of use of nature. You as a domain expert or process engineer who might be very good in, let us say, the welding system or pressing system or any processes, or even that for that matter, let's say the heat treatment process itself, you can simply seamlessly change the workflow or even create your own new workflow depending on the business use case. That is how it will be getting into the future. Already some no code, low code development platforms are there. Right now, I'm not talking about certain things which are actually the platform level, but I'm addressing you as a software developer can make use of this Google Blockly, Node-RED, and even for that matter, LabVIEW to create these kind of low-code, no-code platforms, to create the platform itself. There are available platforms. Again, Ignition is one of them for automation. But trend is with this, we get into something like almost 50 to 90 percentage of acceleration in the development of the workflows itself. And if you see, even for that matter, Gartner has kind of predicted, at least by 2025 or maybe in next year, we would be seeing that 80% would be an empowered workforce. In the production, you need not always rely on the software developers, but at the same time, the software developer will be taking the complexity of generating or developing this kind of no code platform. You as a domain experts and process engineer will be using this one, will be empowered to actually apply your core fundamental engineering knowledge to bring some value in your production line. That's how this no code, low code development would look like. When you think of this, the next extension would be the model-based system engineering, which means you, of course, will touch upon the digital twin in the next slide, but right now we are focusing on those model-based system engineering, wherein which you actually physically, what you see the plant or a particular operation, before any machine is actually rigged up, you will try to model it using some platforms like obviously you would have started with this knowledge of getting to know this Katia and other Autodesk and all. Similarly, we do have other other toolings like softwares like Katia, Rhapsody, including even MATLAB and Simulink. Of course, the MATLAB and Simulink is trying to have a different perspective. It is more on this dynamic control behavior, where the other more focuses on the system architecture or even simulation angle. So that way, if you see, a huge advantage with this is the virtual commissioning, wherein which you started modeling the physical plant with your domain and process knowledge, and then you kind of tested at the controller level without even a machine is available to you, only the controller is there. And once satisfied, you will even generate a production ready code also, and then finally deploy into the controller, wait until the machine is rigged up and test and maybe bug fix. This is the trend. And what even Gartner suggests is that is this so-called model-based engineering would be converging with other technologies like simulation and AI within the PLM. What we try to say the PLM over here is the product like life cycle management, wherein which I start with the idea concept or and then go for the design and then development and then production and then finally release to the market and then even let's say dispose. The whole of this system can be integrated seamlessly, and this would be converging in such a way that the so-called, if you imagine there is something like a product called product lifecycle management platforms or product solutions, the model-based system engineering would be kind of integrated with simulation and AI within this PLM itself. So model-based system engineering is something is to be looked upon, wherein which you can easily validate your system, generate your code. Basically, you have just started to kind of set up the next wave of this so-called digital twin and AI integration. Here we are talking about, of course, most of the sometimes the digital twin is sometimes it's also kind of having a root of model-based system engineering itself, but it also has other digital aspect to it. That is where an entire now a virtual model of the physical asset, including the process, can be actually kind of models, and then it can be integrated with AI also. Of course, there are some standards over here. When we think about this digital twin, imagine as if it is a digital replica of your physical asset. It may not even be a system or a machine, it can be even a process also. All this can be modeled. And there are some couple of standards. One which we are more focused in industry, we are more focused on this ONNX, wherein which we call it as Open Neural Network Exchange. This AI model, you cannot have your own model and then, let's say, deploy across multiple hardwares. We need some kind of standard system to contain those things that can be kind of portable across many hardwares and software frameworks. This ONNX is something which is to be explored. And at the same time, from a digital twin aspect, this so-called asset administrative shell is something again the emphasis is on this, so that there will be a lot of digital twin from multiple software suppliers, but the interoperability between them would be a challenge. Again, to address that one, this AAS will come into picture. What do we get out of this? Yes, we do have digital twin with these kind of standard with AI integrated. That is where the convergence is trying to see, where we started with this low code, no code that can take a shape of even this model, and that model is now kind of appearing in a digital twin, and that digital twin is again integrated with AI. All in all, you're trying to see an entire kinematic and dynamic simulation is possible without a actual machine being there. It can even pave the way for this predictive maintenance and process optimization in one, let's say, platform in context itself. This is how the future would be looking like, and what is that you would be getting out of it. Yes, from an industry academic bridge, there is definitely an opportunity and challenges. You can treat these challenges an opportunity. It's the way in which we pick it up. But what are those? Specifically, try to follow some trends in the market. Specifically, we from industry follow this Gartner, McKinsey, and World Economic Forums and all. If you see in that context, the market trends, what Gartner is trying to say about the manufacturing operation itself suggests that we have this, of course, we have this hype curve. I'll just highlight what it more focuses on. One is, like Sachin mentioned, the aspect of sustainability, specifically from the energy efficiency. This is something which we need to really work in industrial automation from a manufacturing aspect. Then comes the asset performance. What do we mean by this? Whenever a product or a particular machine tries to do some particular product, its efficiency will be deteriorating. At the same time, how can we optimize that one is somewhere this asset performance management will be focusing on. Here, yes, the scope is not limited to only machine. It can be even other parts of the assets, whether it is somewhere, let's say the machine or logistic part of the manufacturing, sometimes including the operator. Yes, again, we have a huge scope of OT security, the operation technology security, wherein which we were having multi-vendor. Now we are more focusing on hardware independent control systems, and that brings a lot of scope for OT security also. Other than this digital twin, smart factory, there is also a concept called lights out manufacturing, sometimes also called as dark factory, wherein which typically it will be more like a golden standard for automation, wherein which you would be having almost anything running from a software point of view. That is where the lights out manufacturing and software defined factory or manufacturing are kind of interrelated. But the golden standard for software defined manufacturing is to implement the lights off manufacturing. So there it talks about, in fact, whether you try to install a software in a control edge, wherein which it can be implemented in some hardware independent nature. Sometimes it can be even imagined that this can even run on cloud itself. Not really the cloud what we imagine, but what the new term is being coined is edge cloud, which means it appears to be as if it is a local edge, but in the context of an on-premise cloud. That's how it will shape out the lights of manufacturing. And again, we have this generative AI in manufacturing, cyber physical system, 5G in manufacturing. So in all, you can see multiple scopes are there from the trend point of view. What is that we need to see from a software? We in the software will try to differentiate certain terms like domains, technologies, platforms, and frameworks. When we say technology, we are talking about domain independent, which means, example, I may use some kind of networking system that can be applied on domains like automotive or manufacturing. I may use the embedded system for automotive or manufacturing. That's how the domain independent technologies are to be treated. Otherwise, we do have these platforms and other frameworks. What is that we will be more focusing, at least for our current talk context, the automotive and manufacturing areas. If you see, embedded and real time is something to be more focused on. Other than this networking called time sensitive network, OPC, MQTT, and REST API for enabling interconnection between multiple nodes. And then, of course, the control system. That's where you as a electronics and communication engineer or instrumentation engineer should be strongly working on these areas, have the fundamentals strong in this. And again, this being implemented from an edge or cloud point of view, leveraging AI, including even the now agentic form. And yes, security and safety is most critical here. In platform, there is always a scope for Linux, RTOS, and Windows. Like even for the graphics point of view, Unreal and Unity, we have MATLAB for model-based, and then Dockerization for the pipelines. And again, frameworks looked upon is this Angular for mobile, some Flutter, microservice, and event-driven, because it is not traditionally the so-called integration issues will be solved through this microservice. And what is to be looked upon is from the function block programming, the IEC 61149. These are the some very software point of view, which would be more having a good scope in the future. Practical opportunity and challenges. You will definitely think from an opportunity point of view, you as a engineer we'll be working on real high impact and real world coding, which means from an operation technology where when we are enabled with this model based low code no code, technically you will be more practically working on real world high impact coding. And then definitely you will be leveraging AI for efficiency. Yes, there is always a kind of dilemma between would it replace me or it will enable me. Think it as an opportunity. It has been enabling for us in the software industry at recent times a lot. What I used to program on a certain complex topic for something like some example 2 to 3 months, it has been possible those 2 to 3 months can be reduced to almost like 2 to 3 weeks or less than that. That is how the efficiency is been improving nowadays. Similarly, obviously, we will be helping in bridging the back gap between the IT and OT, and then enabling the software-defined factory. What are all the challenges? Yes, like Heba sir tried to mention, one is mastering the core fundamentals, be it mechanical, electrical, software, or even other branches where the fundamental course, which is often required in industry, specifically in the manufacturing sector, this core fundamentals is required. And then how do you apply this safety, security, and reliability? From a if you think from a software angle, it is not possible that you can ignore this safety, security, and reliability. This thought process should be there. It is not like I simply develop something and leave it. These things we call it as non-functional requirements. You may be asked to pick and place a particular robot, but you should be aware that this non-functional requirement like safety and then security and reliability should be part of it. Similarly, navigating the legacy modernization. Currently, in the manufacturing sector, not everybody is in industry 4.0. Forget about industry 5.0 or what we call, try to say it as software defined factory. There are very few so-called lighthouse companies which more focuses on industry 4.0 and beyond. But practically speaking, in the global environment, there are many companies or many manufacturing industries which are less than 3.0 itself. That is where a lot of legacy systems are still there. This is where the opportunity can be converted into some business outcome. But the challenge is trying to understand those legacy systems and trying to provide a modern equivalent of that is something you need to have the thought process. And of course, we mentioned multiple times, it is the only way that I cannot be a web developer alone. Why do I need to do the web development? Why do I need to do the control system? From that angle, if you see, from a control system point of view, specifically in the industrial automation, acquiring interdisciplinary knowledge is very, very important. And for me, what did I do in the maintenance engineer? I focused on mechanical things, electrical things, and bit of software. That skill is been helping me to think how all conclusion specifically from the inevitable convergent context, software defined future or software defined factory point of view. It is our future. Next is the professional empowerment. It's not only the software developer would be thriving, there will be a ramp and upsurge in non-IT or non-software also to empower with this kind of automation things that you can engage in some kind of high level design and optimization things. We saw that part from a workflow optimization or creating our own optimization workflow. Likewise, we mentioned a lot about innovation and efficiency. This is very crucial, wherein which, whether it is Bosch or any other company, we are investing on the perspective of innovation, specifically from getting into faster time to market and at the same time efficiency. You cannot be a programmer who will be taking time to develop certain simple things or a mid complex thing. Yes, it has to be within some months or something like this. How do you get into improving this efficiency? using AI and other stuffs. Likewise, what would be the benefit for the business? Here, with all these kind of future software-defined factory, professional empowerment, and innovation, finally to lead to that reduced total cost to ownership for the business. This is how finally the business or the industry really wanted. One, to be competitive in the market, wherein which literally, see, one point I want to emphasize: when you try to think from this Anand Mahindra view of this manufacturing was underappreciated, even Elon Musk kind of acknowledged that we do many innovative things and we struggle and even attempt to do all this efficiency improvement and optimization. We get to a certain point, but still there is lot scope, because finally it's not that everything all these pays certain benefit. It's only when you think from the business first and then technology less aspect, that thought process, if you keep coming, whether through entrepreneurial skill point of view or the approach point of view, or an inbuilt, let's say, innovation within the company projects itself, this is the way future. So with this, I want to conclude. Thank you.
Hey Kiran, yes. Thank you for this interesting perspective on convergence. So, from the attendees, are there any questions? If not, I think if you look at the talks from all our experts today, I think Mahesh and Sachin both had to sign out. They had some work, so they had to leave. But I think Kiran is still here with us. And before we close our session, we'll just, if you draw the thread here, I think there are some few key aspects which all these three guys have actually highlighted, and I'll just mention those things here. One is interdisciplinary knowledge. I think all of them talked about it, and how interdisciplinary knowledge is very, very important for students going forward as they go ahead and build their careers. Just limiting ourselves to one particular domain is no longer sufficient. I think it is a requirement of the future to have, yes, we have our own expertise, but we need to know other things which together complete the system, right? I think Kiran also stressed on that. And also looking at how different software defined systems are taking shape across all the spectrum. Kiran talked about it from a manufacturing and automation perspective, how a decoupling of hardware is happening, how going forward newer virtual systems are going to be designed. And manufacturing has been, I think, a little slower compared to, because legacy manufacturing systems have taken over the couple of decades, have become so strong and so stable. Just moving to a new system, I think, is hard. So Kiran, from that perspective, I want to ask you, from a student and faculty perspective, just 1 second. Some student and faculty perspective, how do you think this, when freshers come into corporations who are into manufacturing, what are the skills they need to be prepared with as they come on board in this changing environment where manufacturing itself is undergoing a transformational change? What
Yes,
skills, technologies, I think you need students to be prepared with?
correct. So from that angle, if you see, of course, there are multiple ways in which the students can enter the manufacturing area. Of course, from the perspective of, let's say, the software, when if I want to start, that is where the new paradigm of this new control system programming, whether you call it as the PLC programming or the new IEC 61499 perspective, the new thought process of the control system programming is to be started to looked upon. That is one aspect of it. Then the other aspect of the software is the model-based system, whether in the context of simple model-based engineering and even integrating with digital twin and AI is something we need to look from a software aspect. Other than the software, even from a process angle, if you see, generally we will be having in manufacturing the mechanical team, the electromechanical, or basically the mechatronics will be a crucial, let's say, the path for the engineers. The more core fundamentals. You grasp the mechatronics, which will be talking about the electrical, mechanical, and even electronics per se. Now try to apply the same thing from an AI point of view. See, it's just the same thing. What the control logics, what we did from, let us say, pick and place, or let's say controlling some temperature of a oven in a heat treatment plant. We used to have some kind of a control logics. With all the data available for that particular element, we kind of say that the paradigm shift again would be something like this. It might be too early for the students, but that is what they can get into. Specifically from a software, I was trying to say this is how the trend is focusing on. But from a non-software, that is people from the process engineer, domain expertise, or even for that matter, maintenance engineer, they will have to focus that how they can apply the same core knowledge using this AI based system, which means the trend would so happen that instead of trying to develop a kind of controller which will be controlling a temperature, you may have a AI model to actually do the same thing. But given the fact that this kind of accuracy, safety related things are still a point of matter, this is how your domain expertise and process expertise will come into picture to make the AI system much more smarter. It is something like AI on its own will may provide something like 80 to 90 or maybe 95% accuracy. It is only through the data and the right data, and you people are the right people who bring the perspective of domain and process angle to say is this the right data or the garbage data. From this angle, that experience of that will be applied onto the AI itself to make the efficient or the right, let's say, so-called prediction or optimization or whatever. That is how you would be trying to more help in coming future. And again, from other skills aspect point of view, from an entry software engineers, yes, good, we start with this so-called AI systems from Python or something like this. But from an initial automation, technically speaking, still we will be having PLC logic for a long time. Because technically speaking, not all the PLC logics can be converted into something. Of course, you can transit. There might be a chance that the transition from the PLC IEC 6113 standard to IEC 61499 standard, so that that hardware independentness you may achieve, but still the context of logic application or the logic implementation will be still relevant. From that angle, more the fundamentals you would be trying to work on the control system point of view. So I mean, I've just touched upon certain part in the operation technology, some things for the non-IT or let us say the process or domain expert point of view, but this is what would happen. And we are kind of seeing this trend from the manufacturing side, where in which once we give these kind of systems, no, again, going forward, the human in loop is always a point. This would be definitely there. What you would be definitely seeing is the workers would be now upskilled. When the workers are upskilled to use the tools of the AI or these so-called new platforms, which are either AI or non-AI based, the low code, no code, and all, still, can they drag and drop certain workflows? If there is something like pick and place and do something, can they drag and drop? Yes, it is quite possible, definitely possible, but the right training should be given. So it's not a challenge, it's possibility. So, but in that context, the workers would be upskilled. Similarly, the engineers also have to be upskilled in their own area from the perspective of trying to leverage these kind of tools, whether it is AI based or even other software elements.
Okay, fair enough. Uh, Raj, you had raised hand. You have a question?
Yes, sir. I have a question.
Go ahead.
Sir, I have talked about the interdisciplinary field or study regarding our fields, such as if we are students of mechanical engineering, we must have knowledge about electrical also, AI also. So, sir, my question is, uh, what topics or how much we should study about another fields. Means
Okay.
actually I'm unable to express myself, sir, here. I don't know why, but
Okay,
No,
I'll add up here. First of all, we need to differentiate this part. How much I need to learn. We all start from the very core fundamentals, right? Whether it is electronics engineer or computer science or whatever, we do have our core areas. What we meant by core is also physics, mathematics, and other related STEM related topics. Be
okay,
strong in
sir.
first the STEM area. If you are good in the STEM area, then you will be now kind of splitting. If you are a computer science, you may as aspire to become, let's say, a digital twin expert. Or if you are a something like same computer science engineer, you may aspire to more be, let's say, some kind of web application engineer. So something like this. Similarly, from the other aspect, from a mechanical and electrical aspect, if you see, you will not be implementing an AI system. You will not be implementing a digital twin from a software angle, but definitely you will be using it, right? Problem with the current industry is people who are very good in technology. For example, graphics, whether it is 2D or 3D, is a technology, right? We used to do some 3D simulation or animation, or even for that matter, extend it to entire digital twin with prediction and all, let's say. While we are good in technology, we may not be good in the domain aspect. One simple example, let us take a manufacturing process called pressing system or tightening system. When a pressing system is being looked upon, what are you trying to see here? A force and distance curve is what you're trying to see, or a torque and distance curve. Similarly, for tightening, you will be focusing on the torque and angle. The way in which a mechanical person sees a torque and angle relation to the tightening or a force and distance with respect to pressing is different from the software engineer. That is where you will be playing a role of something like that kind of a process expert trying to use this kind of AI and non-AI based system to make the actual process much better and create your own new process. That is where you want to distinguish yourself. Are you a creator of the AI or are you a user of the AI? Think from a user point of view. Lot of opportunities would be there. There in that aspect, how to use it is more the learning you need to focus on than to create from your question point of view. Hope I answered.
yes, sir. I got it, sir. Thank you so much, sir.
Yeah, I think
Yeah.
so. Raj, just to add to, I think Kiran made a fair point. I think using the technology, you don't need to go in the intricacies of AI to figure out an AI model and how you train that model. You don't need to do that. But how do you use it smartly to do the job better? At the same time, I think there is this T model of learning. Okay, if you have learned about it before, where the T represents how you learn and what your area of the expertise. If you know how the T looks, so T is as a vertical line. That vertical line basically represents the depth of expertise that you have built. It may be around one or two or three core areas, and that you don't build now, that you will build over time. Okay, over time, when you kind of progress further in your career, you will build that depth of understanding and capability that will be the center of the T. But at the same time, you need that breadth of knowledge if you choose to become part of an automotive industry, for example. So right now, like in colleges, they don't teach anything about industries. How industries
Yes,
work, I
sir.
think, is not really understood by students. But that is something you would learn, and that is why you should attend some of these sessions where you will get some insight in what people do in automotive. How does the automotive industry work? And that is something you should also focus on. If you are interested in a particular kind of industry, take that effort to learn more about that industry, how it works, what kind of products, what kind of technology is being used. I think those kind of efforts will help you. I think it's been a fantastic session so far, and just give me a second here. Yeah, I think it's a good start to our sessions. I'll just quickly summarize some of the key points that all our experts have made today, and just a summary of the essentials that are important for engineering students to keep in mind. So one is most top of the mind that I have is focus on fundamentals. Okay, what you are learning now in part of your course, those are the fundamental aspects, whether it whatever your stream may be. But ensure that you understand those concepts, understand how it works, and you are in a position to now internalize it and apply it as it comes. So focus on fundamentals. Second is interdisciplinary knowledge. Interdisciplinary is not about becoming an expert in some other area, but you need to have some understanding, some outside in view into what is that all about, right? So when you talk about electronics, okay, you need to know, okay, some basics of that. What is that electronics? How is it being used in certain products? Because all products and all solutions that you build will not have just one tech alone. It will have mechanical, electronics, electrical, all those technologies together form a solution. And coming to solutions, I think during our intermediate discussions, we discussed about as an engineers, what is our primary role? Our primary role is to solve problems, right? The problems that you encounter in our daily lives, whether personal, or professional, or industrial, at whatever scale you do, but in the end, we solve problems. So as engineers, you need to keep your eye open to understand where are those problems, what are those opportunities that need solving, and you should have a technological solution to do that. Next point is, okay, leverage of AI and software. As you heard our experts, AI is no kind of merging into each and every field. So you don't need to know the technicalities of how to develop AI models, but definitely know how to use it smartly to get your job done, and how you can use. Also, you understand the pros and cons of it. It is, you cannot use it blindly, but understand what it can do and what it cannot do, right? Other option that we also discussed during our discussion today was, while you are worried about jobs and as you go forward, we are looking about opportunities, but entrepreneurship is a viable option. If you are good in your understanding, you are able to find certain problems to solve, you can actually opt for an entrepreneur option where you actually make a product and test it out and experiment with it. So definitely look at that. If you heard our first session from Mahesh, he talked about how big corporates today nurture startups within themselves. And Kiran is from Bosch, and I have been part of Bosch earlier. So Bosch is a great company which actually nurtures startups within the company itself. You can be even you can be an employee, and at the same time you can if you have the right idea, you can pitch it, and you will get an opportunity to run that project by yourself with support from management. So that's, and finally we look at, other than all the technical skills, if you heard Sachin he talked about all the cross-functional as well as soft skills that are needed. So focus on your communication and presentation skills, which are very, very important as part of being part of a corporate job. Ability to articulate your idea in English. English is the language of business. So ensure that you are able to articulate your idea, secondly, and briefly in the right way, in the words that you mean. So focus on that, build on your presentation skills and communication skills. And finally, learn about industries, learn about different kinds of industries, uh, because in the end, the vertical domain is very, very important, where you actually apply your problem solving skills. And for each industry, there is a set of regulations, like Kiran also talked about, so many regulatory standards which shape manufacturing, right? So as you get onto the job, those kind of standards become very, very important. Those are the boundaries under which you actually develop something, create a product, software, hardware, whatever. So that's about it. Thank you for being part of the session today. I think we have been recording this session, so we will release the recording, and I hope that in future more students will take benefit of certain sessions and experts who have here. So I'm going to type my email ID in the chat box. Anybody wishing to communicate, if you have questions even later, you can go ahead and post it to me, and we will try to get it answered from the experts who have been on the panel today. So thank you guys. Thank you so much. Thank you, Kiran, for being here. And that's all. We'll be closing the session now.
Thank you and all the best.
Thank you. Bye.